In this lesson, we will discuss standard normal distribution. So first of all, I will explain to you the meaning of standard normal distribution. See, the standard normal distribution is the normal distribution. One is the normal distribution and other is the standard normal distribution. So you have to clear the difference between these two. What is the meaning of normal distribution and what is the standard normal distribution? See, this is the normal distribution. This graph is the bell-shaped graph, or it is also called the Gaussian graph. So this is the normal distribution. See here why it is called normal, because both sides of this center line, this is called the mean. Whatever data you have, whenever you will calculate the mean, if the mean lies at the center, same amount of data you have on the right hand side, same amount of data you have on the left hand side. When you will make the graph, always it will show bell shaped graph, right? And this is symmetric. From here, symmetric means both sides. See, you can see here on the left hand side and you can see on the right hand side, both sides have same amount of a data. So it means this is the mean, this is the mode, as well as median, right? Three of them lies here: mean, median and mode. So this is the normal distribution. This is, suppose if the mean is 0 and this is 1, this is called the standard deviation. This is one standard deviation. Here you have 2, positive 2, this is 3, right? Similarly, here on the left hand side, you have -2 and -3, -1, -2, -3. So from one standard deviation above, on your right hand side we will say above the mean, on left hand side we say below the mean, right? So if you have a standard deviation of 1, it means above the mean or below the mean you have equal amount of data, that is 34.13% here. On the left hand side, on the right hand side, if you have a, this represent the standard deviation if you have a standard deviation 1. So total from here to here, see, I have mentioned a line from -1 to +1 above the mean, or here we can write down mu plus 1, because this is the mean and mean is represented by mu. So mu plus 1, mu plus 2, mu plus 3. Here you can write down mu minus 1, mu minus 2 and mu minus 3. So the area between -1 and 1 total is approximately, right, I will write down 68 point some percent. I will make a round figure which is 68%, but it is a little bit more than 68%, right? If the standard deviation is 2 from here to here, then you have to add 13.59 to this 34 as well, and same thing 13.59 to 34 as well. So from here to here, approximately it is 95% of data falls within 2 standard deviation. 2 standard deviation on this side we will say above the mean, here we will say below the mean, and it is again a little bit more than 95. I'm just writing the rounding figures. If the standard deviation is 3 above the mean or 3 below the mean, so it is 97 point something, make it just 97% data lies here. This is the normal distribution. But for the standard normal distribution is also a normal distribution with a mean of 0 and a standard deviation of 1, right? I will give you the example. Suppose if you will say that your school or your college is, suppose, 5 kilometers from your house. Your school or your college is 5 kilometers from your house. So we are saying that 5 kilometers from the house. So in normal distribution, in standard normal distribution, this is the unit. Standard deviation is the unit. We will say one standard deviation above the mean. Same thing. We measure the distance from the mean, or whatever the number from the mean, in standard deviation. Same thing here, right? The values under the curve See, this is the curve. This is the curve. Show the proportion part of the area in each section. What does it mean? Each section is standard deviation of 1, standard deviation of 2, and standard deviation of 3. The area between the mean and if one standard deviation above or below the mean is approximately 34.13%, which I have told you. Since it says here, since each normal distribution variable has its own mean and standard deviation, what does it mean? Suppose variable, it says each normally distributed variable. Now you should be clear what is the meaning of normally distributed. On both sides data should be equally divided. Both sides of the mean data should be equally divided. So what is the meaning of variable? Suppose variable is any attribute that can have different values. So suppose here I will take 30 patients and I will check their blood pressure. Suppose the systolic blood pressure is for the first patient is 120 and then 110 and the third is 140. Suppose the other is 150 high blood pressure, right? One is 98 low blood pressure. This is the systolic blood pressure. So I will make the mean of these data and then I will find out the standard deviation. So this is one variable. Now suppose here I am taking the height of the women, right? Suppose it is 5.4 inches, one woman, second is 5.2, right? Or 5.5, or one is 4.8 inches, different height. So just we will make the total of this, we will take the mean. See, if suppose we are taking 10, so make the total divided by 10. This is 30 patient, make the total of the 30 blood pressure and then divided by 30, you will get the mean. Then we will find out the standard deviation, which we have discussed already, how to calculate the standard deviation and variance. So see, these are different variables. These are the heights, these are the blood pressure. So each, it says that each normally distributed variable has its own mean and a standard deviation. So this variable has own mean. We cannot say that these two have the same mean, same standard deviation. No, this is different, this is different. So this has a different mean and standard deviation. This has a different mean and standard deviation. So from this point we conclude that this shape, the shape of this curve depends on two factors, which is mean and the standard deviation. Mean and standard deviations. And these shapes are different for each variable. Why? Because each variable has its own mean and own standard deviation. Right? Suppose for this is the first variable and the mean is 0. If I will say the standard deviation is 1, suppose the standard deviation is 1, so you will get this kind of curve. But if I will say mean remain the same, suppose I will calculate and the mean is same, but the standard deviation varies, so you will see the graph will be like this, spread out. So it means as the standard deviation increases, the shape of the curve spreads out. Right? So now I will read one more time for you. Since each normally distributed variable has its own mean and standard deviation, the shape and location of the curve will vary. In practical application, when we will solve the problem in the next few slides, I will show you how to use the table and the technology. We will use the Microsoft Excel. In this lesson, I will show you how to use the table. In the next part, I will show you how to use the Microsoft Excel in order to calculate the standard normal distributions. Right? Okay. So for the formula for the standard normal distribution is y is equal to e raised to power minus z square divided by 2, then whole divided by square root of 2 pi. So then here you have to put the value of e, which is 2.718. Then you have to find out the value of z square, right, divided by pi. Pi is 3.14. So this formula is tedious. is difficult, right? But you should know that if someone asks you what is the formula is this to calculate the standard normal distribution. But here we are not going to use. Statisticians prefer to use the table or the technology to find out the standard normal distribution. Okay, now move on to the next slide, and I will show you the formula. See, normally distributed variables can be converted into a standard normal distribution variable. What is the standard normal distribution? Standard normal distribution has a mean of 0 and a standard deviation 1, right? So we can convert normally distributed variables, whatever figures we have, whatever data we have, into a standard normal distribution by using this formula. This is called the z-score. Z is equal to value, whatever is the value of your data, minus mean. You have to calculate the mean and standard deviation and divided by standard deviation. For samples, you have to use this formula. For population, you have to use this formula to calculate the z-score. Right, one more time I will explain the difference between population and sample. Suppose if we have a 20 students in class, and if I will say, okay, 20 students have to do the evaluation, right? So if I am considering 100% student, this is called the population. But if I will say only I will pick randomly 5 people students or 6 students, this is called the sample. Right, for sample, standard deviation represents xs, and for population, standard deviation represented by sigma. So this formula, keep in mind, we have to use when we convert the normal distribution variable into standard normal distribution. In this lesson we will not going to convert, but in the next lesson, yes, we will convert the amount into standard normal distribution. So how, there are 2 points: finding the area under the standard normal distribution curve of any z value. See this one, this one, this is the standard normal distribution, right? So you have to find out the area. There are only 2 steps, and it is very simple to find out the area under the standard normal distribution. First of all, you have to draw a curve. Draw a normal distribution curve. First you have to draw this. Then shade the desired area. Suppose if I will say the z, this is the mean, and the z value is 1.2. So see, the right hand side you have to write down the positive numbers. On left hand side is the below the mean, this is above the mean, right? So this one, here is the 1 standard deviation, 1.2 means slightly here. So just make a line, right? If I will say to the left, we have to find out the area to the left of z value. So this is the z value, right? And this is the area. All area is to the left. So second is that you have to shade the desired area that you want to find out this. Draw normal distribution and shade the desired area. And second is, then you have to find out this 1.2 in the table. I will show you, and then write down the answer. What is the area? 3 kinds of problem we will solve here. First is to the right of any z value. See, what does it mean? This is the normal distribution. First, I have told you, you have to make the normal distribution, and this is the 0. First is to the right of the z value. Suppose if -1 is given, -1, right? So you have to find out this area. This is one type of question. Other is to the left of the z value. Suppose here is 1.2. So make a line here and then shade this portion. You want to find out this. Third is between any 2 values. Here, this is suppose in the center. Here I will say -1.4, and here I will say 1.8. Suppose This is the Z value. Make a line here, and this center portion. Shade this area between any two values. So one will be negative, one will be in positive. So there are three types of problem we will solve here, right? First is find the area under the standard normal distribution curve to the right of the Z value. Right. See, this is the right, and Z value is given. What is the Z value? Negative 1.54. So negative is below the mean. This is mean below the mean. Just write down. See, here will be one standard deviation. It is 1.5. So we will write down a little bit here. So this is the, so make a line here. This one. This one. This is the first point. First you have to draw normal distribution and then shade the area. You have to find out to the right of Z. This is the right of Z. So just shade all this, that you are, this area is required. And then this table, see, again I am saying that there are different kinds of table. So you should know, here we are learning standard normal distribution. So this table is called standard normal distribution table. If you will search, you will find out this table, but if you have a book, you can find out at the end. There are different ways to find out this table. This is called the standard normal distribution table. And see, this is the Z value, this one. So when you will see there are Z values, positive Z values, it starts from negative 3.4, positive and negative. So this is negative 1.454. That is why we are looking for the negative number. So see, 1.54. For this, I will show you how to consult this table. The first two, 1 point decimal 5, you have to find out from this Z value, this one. And the last is 4, you have to find out from here. So this is 4. Right? Okay. So this is negative 1.5, this one. And then come down from here where it coincides, this one. 0.0618, 0.0618. This is the value. I will show you how to use this in the Microsoft Excel as well. But see here, this is negative, and the question is to the right. We want to find out the area of this. So if it is, you want to find out the area of the right side, then keep in mind you have to subtract 1 from this value. 1 minus 0.618, and you will get 90.9382. Multiply by 100 in order to show your answer in percentage. So it will be 93.82%. So this area is 93.28%. And you can see only this is blank, right? This is, so it means total area is 100% or 1. Right, so out of 100%, this required area is 93.82%. If you are looking for the right side curve to the right, then you have to subtract the value from 1. Right? Okay, the second question is, now find the standard normal distribution curve to the left of Z value. Left. First part is you have to make the curve and 2.02. So this is standard deviation 1 Z value, or this is the Z value 2.02. We will say, okay, this is 2.02. It means it is above 2.02 from the mean. 2.02 is standard deviation above the mean. So just make the line here, and the which area you are looking for? Left of the Z. This is the left of the Z. So shade it. I did for you. This is the first part. Now the value is 2.02. See, here is standard normal distribution curve, but these Z values are in positive. Here it is in negative. You will find out these values in the table. But this is positive. That is why do not consult the negative one, the positive one. So 2.02. Again, I will show you how to consult this table. The first whole number 2 and then decimal 0. These you have to find out from this column, from the Z value. and the last one you have to find out from here horizontally, and then we will coincide. So see, 2.0 is this, 2.0 is this, and then this one is 2. So it is 0.9783, which is equal to 97.83%. So this area is 97.83% to the left of our Z value, which is 2.02. This is left, right? If you are finding the area on the left, there is no need to subtract this value from 1. But if it is you are finding the area of right, this, yes, you have to subtract the value from 1. The third is find the area under the standard normal distribution between these two values. I have told you between. One is positive 1.43, so positive it should be here on the right hand side, and this is negative 1.12, write down 1.12 here. So now you have to consult both tables. 1.43 for positive 1, 1.4 you have to find out from this column Z value, and then 3 we will find out on the horizontal row. So 1.4 this one, 1.4, and then come down here where it coincides 0.9236, 0.9236. And then is the negative one, same thing, minus 1.1, and from here you will see 0.1314. We have to find out this area, right? So subtract the positive number from the negative number. This is for this value positive, this is for the negative. This minus this is equal to 0.7922. In percentage we will say 79.22%. So you have learned how to find out the required area under the standard normal distribution curve by using the table, right? Here I have set some practice problem for you. Find the area under the standard normal distribution curve to the left. See, left of the Z value. This is 1.89. What you have to do, first thing is you have to make a graph, and then 1.89. Suppose it lies here. So shade this area and you have to find out 1.8 from the Z value and 9 from here. Then here I have mentioned the answers as well. But first you have to solve this question. In this case, you have to subtract your value from the 1 because this is to the right of the Z value. This is the negative Z value. And here are the two values. So practice problem you have to solve. If you still have any question, you can write down in comment section. In the next lesson, I will show you in this second part, find the areas under standard normal distribution using Microsoft Excel, right? So thanks for watching, but please do not forget to subscribe to my channel on YouTube, Saima Academy, and thanks.